Hey guys, okay, so this is going to be the quiz review for you since I'm not going to be there. And the way to know if this is your quiz is you either start with 6.1 times 10 to the third or 6.1 times 10 to the fifth. This is obviously 6.1 times 10 to the third. So to do this problem, we're going to multiply these two numbers. So it's 15.86 times 10. And then we're going to add the exponents since they're side by side to the 8. Now the problem is that I'm only allowed to have one number in front of the decimal, so I need to back that guy up one, and I'm going to end up with 1.586 times 10. Okay, I backed up one, which means I need to add one here to make it bigger. On the second problem, we're going to divide 8.4 and 2.4. So we're dividing these two numbers, and we're going to get 3.5 times 10. And then, as you remember, I subtract exponents here. So it's times 10 to the negative 15. Negative 6, subtract 9. Okay? And that would be my answer. Now, quick reminder, there is a calculator on this test, just like there was on the quiz. So you can do this in your calculator to check your answer, but we're going to need to make sure to see work. Okay, lots of ways to do exponents here, but the way I'm going to do it is I'm going to, this first one, I'm going to multiply all of these. So I'm going to multiply 2 times 8, and I'm going to get 16. And then if I multiply the m's together, sorry, I'm at McAllister's, that I would get m. I'm going to add those exponents, and then I'm going to do the n's, and again I'm going to add those exponents. Negative 1 plus negative 2 is negative 3. We all know we're not allowed to have negative exponents, so I'm going to rewrite this, and I'm going to put the negatives in the denominator and make them positive. Okay, over here, it's really easy to forget that numbers are numbers. So what I'm going to do first is I'm just going to simplify 6 over 14. 2 goes into both of those, giving me 3 over 7. Okay, and now when I have a fraction, I don't like these negative exponents, so I'm going to go ahead and move them. That e to the negative 3 in the numerator will go to the denominator. The f to the negative 2 in the numerator will go to the denominator. This e to the first is positive, so he will stay down here. And the f to the negative 4th is negative, so he will go to the numerator. Okay, so now I have 3 over 7. And if you think about the f's, I have f to the 4th in the numerator, and I have f squared in the denominator. 2 of those pairs will cancel, leaving me f squared in the numerator. And then these guys are side by side, so I'm just going to add those exponents together and I'm going to get e to the 4th. Okay, I know I'm not done in this area right here because I have multiple f's and I have multiple e's. Okay, you're not done until you have one of each letter. There can't be multiple variables that are f. In order to do the degree of this, the first thing I need to do is to put it in standard form. So you start with your highest exponent, go to your next lowest exponent, and end with your constant. So now the degree is going to be the degree of my first term, that's a cube, sorry. So the degree is going to be 3. The leading coefficient is going to be the number in front of the highest degree. This would give me, there are 3 terms, so it's called a trinomial, and degree 3 is called a cubic. Okay, it's getting louder in McAllister's, so we're going to use direct substitution to evaluate this. So f of x equals 3, directly substitute in the negative 1, minus negative 1 cubed, plus 2, plug in negative 1 squared, minus 5, plug in negative 1, plus 7. That looks a little light, so let's change that color. Okay, so now negative 1 to the 4th is going to be positive 1, so this is going to be 3. Subtract negative 1 cubed is negative 1. Negative 1 squared is positive 1 times 2 would be plus 2. Negative 5 times negative 1 is plus 5 plus 7. This will turn into a big positive, so we have 3 plus 1 is 4, plus 2 is 6, plus 5 is 11, plus 7 is 18. Final answer. Synthetic substitution. So remember, with synthetic, I'm going to substitute 2 in. Don't get this confused with synthetic division, which we did yesterday in class, or Tuesday in class. I'm going to divide. I don't think I'm missing any exponent. Nope, all the way down, so I don't need to leave a 0. So I'm going to pull this down. I'm going to multiply 2 times 7 and put it here. Add those. Multiply 2 times 11 and put it here. Add those. Multiply 2 times 23. Add those. Multiply 2 times 51. Add those. And I get 93. So I know that the point 2, 93, is on that graph. Okay, on this, end behavior is based on the degree and the leading coefficient. The degree and the leading coefficient. The degree in this number is 7, so the degree is 7, which is odd. And my leading coefficient is negative 4, which is negative. So this is a negative odd. So on my graph, it would end, nope, that's positive. So we're thinking about a line. So a negative line goes like this. Okay, a line is an odd. So I have to write the two sentences. As x approaches infinity, so as x goes this way, f of x approaches negative infinity. As x approaches negative infinity, which is this way, my function is going to infinity. Okay, over here I have a degree of 8, and I have a leading coefficient of 2, positive 2, and 8, which is an even. Okay, remember in a graph, I compare an even positive to a quadratic. So my two sentences, as x approaches positive infinity, so as x goes this way, my function is also going to positive infinity. And then in reverse, as x approaches negative infinity, so this way, my function is also approaching positive infinity. So here we want to write an expression for the volume. So I know that volume of a cone is 1/3 pi r squared. This is my r. This is my h times x squared. So I'm going to multiply that all out. 2x squared is 2x times 2x, which gives me 4x squared times x squared. Okay, so I'm going to multiply my numbers. So I have 1/3 times 4, which gives me 4/3. I have the pi, and then x squared times x squared. Remember, I add the exponents, gives me x to the 4th. Number 13, a lot of mistakes here are made because people tried to distribute over the addition sign. All I'm doing here is adding this polynomial to this polynomial. I'm going to combine like terms, so I have 3y squared plus y squared is 4y squared. I have negative y, subtract another 6, so I have subtract 7y, and I have 7 minus 9, which would give me negative 2. Same thing here, I'm not multiplying, I'm subtracting, so I have 5w to the 4th minus 2w cubed plus 9. This subtraction distributes in and gives me plus 2w to the 4th minus 8w squared plus w minus 2. Combine like terms, I have 5w and 2w to the 4th, so 7w to the 4th. This is my only cube, so minus 2w cubed. This is my only squared, so minus 8w squared. This is my only w. And then plus 9 minus 2 gives me plus 7. Here, I'm going to distribute this term into here. So I'm going to multiply 5 times 4 gives me 20. X squared times x gives me x to the third. And z, nothing in there, gives me z. Now I'm going to distribute this to the next one. 5 times 2 is 10. X squared, z. This is quote-unquote foiling. I prefer to call it distributing. So if you like to call it foiling, it's the same thing. Multiply the g, 2g squared, multiply by the negative 3. Now I'm going to distribute the 9. And then I'm going to multiply the last two numbers. If you like to do FOIL, this is F-O-I-L. The only problem is FOIL only works for binomial times a binomial. And, you know, I just liked FOIL is the same thing as distributing. I'm going to combine these like terms, so I get 2g squared plus 15g minus 27. Okay, number 14, g times, I think I just did that one. Yes, I did. So I'm going to move to 15. 2a minus 1 squared is like saying 2a minus 1 times 2a minus 1. So you could distribute this out, which would give me 4a squared minus 2a minus another 2a plus 1. Okay? Otherwise, if you realize 2a minus 1 is going to give me a perfect square trinomial, I can square the first. 2a times 2a gives me 4a squared. I can multiply 2a times 1, negative 1, gives me negative 4, negative 2, and double it. That gives me that term. And then square the last. So this is square, multiply, and double. And this is square the last. So square the first, multiply the 2, and double it, and square the last. If you don't know that pattern, it's easier just to write out two binomials. The same as z minus 5, there is a trick to learn, and it's called SCUMS, but in my opinion, there's no sense putting something in your brain to memorize for one test. So z minus 5 cubed is z minus 5 times z minus 5 times z minus 5. So I'm going to multiply out the first two binomials, so I get z squared minus 5z is minus 10z plus 25. And then I'm going to multiply z minus 5 again. I get z cubed minus 5z squared. I'm going to multiply negative 10z times z is negative, and I'm going to stack it. So then I'm going to put the negative 10z squared here, plus 50z. Then I'm going to distribute the 25, so plus 25z minus 125. Combine like terms. When you stack, the like terms are in columns, so this would give me z cubed minus 15z squareds plus 75z minus 125.